Hello friends, welcome to the next session on design of compression members. We'll take up next case of problem. Design a column section consisting of 4 angle sections arranged in a box of 400 by 400 mm to carry axial factor load of 2500 kilonewtons. Height of the column is 5 meters. Both the ends are fixed. So PU is 2500. Both the ends are fixed. So LE is equal to 0.65 L. So LE is equal to 3250 mm. Now I have to arrange the column sections. So it is given that you have to use 4 angles to form a box of 400 by 400. So you can provide the 4 angles like this. So this will make a box section. So this dimension is 400 out to out dimension, and this out to out dimension is 400. So these are the box sections. Now as usual, same design steps. Assume FCD is equal to 220 MPa. You can assume anywhere between 180 to 200 for column sections. Next, area required. Remember, this area you have to provide 4 angle sections. So this area is for 4 angles. 4 angles together is equal to 2500 into 10 raised to 3 divided by 220. So you get the answer 11363 mm square. Area of one angle. So this is for 3 angles. So area of one angle is 11363 divided by 4. So you get 2840 mm square or 28.4 centimeter square. Hence area of one angle will be 28.4 centimeter square. Now you have to choose one angle whose area is little more than 28.4. So refer to the steel tables. From steel table, so always remember, go for equal angles where both the legs are same. The reason is, if you choose unequal angles, you will have to find IXX and IYY differently. Here in this case, when both the legs are same, IXX and IYY will be same. So choose an angle with 28.4 centimeter square. So I have the section here, this one. ISA 130 by 130 by 12, 29.82. So I will be going with this section. ISA 130 by 130 by 12, 29.82. So choose from steel tables, choose one ISA 130 by 130 by 12. So this is for one angle. Provide 4 ISA 130 by 130 by 12. 1, 2, 3, 4, 4 ISA. Now let us draw a diagram to show the details. Say I am going to provide 4 angles like this. When you are providing 4 angles, let these be x axis or ZZ is same, this be YY axis. Now from steel table get these values. So this dimension is 130, this is 130, this whole outside to outside is 400, so 400 minus 130 minus 130, so you are left with 140 mm. 140 is the spacing. Compulsorily you have to provide this much. Now write the properties of one I section from the steel table. For one ISA 130 by 130 by 12 area is equal to 2982 mm square. Get the value of Ix and Iy. Both will be same. 473.8 into 10 raised to 4. Now if you look at the I section, the values are given here. 130 by 130 by 12, Ixx and Iyy. Here, these values. 328.3. So these are the values for ISA 130 by 130 by 12. Sorry, 473.8. 473 by 8, 130 by 130 by 12. It's here. 473 by 8. This is my Ixx and Iyy. 473.8. Now you have to identify Cyy value. Now if you look at this table here, this gives Cyy and Cxx. Since both the legs are same, Cxx and Cyy will be same. Now in diagram there might be this confusion, what is this Cyy and this is Cyy. Actually this Cyy is nothing but Eyy, eccentricity. I have to choose this value from this end to this end, Cyy. So find the value of Cyy value. So Cyy for 130 by 130 by 12, 36.66, this value. Cxx and Cyy center of gravity distance, where you have to provide the S values. 130 by 130 by 12, I have the value 36.66 mm. So Cxx is equal to Cyy is equal to 36.6 mm. Now these things are finalized. Now I have to find Ixx and Iyy for the whole section together. Let me mark those values here. This is Cyy, Cxx. Both are same, 36.6 mm. Now this dimension from here to here, it is 200 and 200. Hole is 400, center 200, 200. Now I can write this section here. Section is symmetrical about Z and Y axis. Hence I minimum is equal to Ixx is equal to Iyy. Now this Ixx and Iyy, capital Ixx and capital Iyy, refers to moment of inertia of this whole section together. Therefore I minimum is equal to small Ixx 473.8, 473.8 into 10 raised to 4 plus area into distance square. Area of one angle. So area of one angle is 2982. Distance square. Distance of this till here. So this from here to here, this is 200. This is 36.6. So this distance will be 200 minus 36.6. 200 minus 36.6 bracket square. Now there are 4 such angles, so multiply by 4. So you get I minimum is equal to 337.4 into 10 raised to 6 mm raised to 4. Now calculate R minimum, radius of gyration, that is nothing but I minimum by A, under root. So under root 337.4 into 10 raised to 6, area 4 into 2982. So 2982 is 1 into 4. So you get 168.2. Now calculate slenderness ratio. Lambda is equal to LE by R min. So LE is 3250. R min I have calculated 168.2. So you get the value 19.32. Now since this is a built up section, buckling class is C. Refer table 9C. From table 9C I have the value FCD is equal to 224 newtons per mm square. Now compressive strength is equal to PD AE into FCD. So AE is 4 into 2982, FCD is 224. So you have the value 2672 into 10 raised to 3 newtons, or 2672 kilonewtons, greater than 2500. Hence okay. So this completes the design. Thank you.